So we're solving x cubed minus 2 equals 0 using Newton's method, paying attention to the fact that the f prime that we're going to be using is 3x squared, and we're using our starting point x1 equals 3. By the way, a lot of books, including yours, call the starting point x0 instead of x1, which is fine. It's totally arbitrary. I used x1 because x1, x2, you know, but a lot of books start with x0, but we can call it x1, doesn't matter. All right, so what are we going to do with x1 of 3? So x1 equals 3. So we need to know, for this formula, we need to know, this is going to be our x1, we need to know f of x1 and f prime of x1. So f of x1 is 3 times 3 cubed, wait, sorry, it's this one. It's 3 cubed minus 2, which is 25, right? Yeah, 25. And then f prime of x1 is going to be 3x squared, so it's going to be 3 times 3 squared, so that's 27. All right, so those were pretty easy to figure. So now we can say what our next x is. Our x2 is going to be our x1. All right, so x2 is going to be, well, let me write this out. x1 minus f of x1 over f prime of x1. All right, so that's going to be, our x1 was 3, minus our f of x1 is 25, over our f prime of x1 is 27. All right, so you see, pretty quickly, this is going to get us into, you know, stuff that we have to do on a calculator. So I can put in here 3 minus 25 divided by 27, get a decimal, got 2.074. So I'm just going to write out 3 decimal places. But although I'm only writing 3 decimal places, don't continue to just use 3 decimal places. We want to use all the decimals in the calculator. Storage space, memory, is cheaper than display space. Therefore, the calculator displays fewer decimals than it holds in calculation. So when I copy this number down into my next calculation, I'm not just copying down 2.074074074. Actually, we can. This is a rational number, so we can see naturally it repeats. But I'm copying down, you know, perhaps 20 decimal places when I copy directly on the calculator without writing down or rounding. So that's what we want to do throughout our calculation, then just only round at the end, which is also, you know, just good calculation practice. All right. So this is what x2 is. Right. So now we're going to find out, we need, in order to get x3, we need to know f of x2 and f prime of x2. That's what we're going to use to get x3. So, yeah, so our f of x2 is going to be our number 2.074 cubed minus 2. And our f prime is going to be 3 times that 2.074 squared, okay? So I can just do this. I want this number cubed minus 2, and that's 6.922. 6.922. And then the next one is going to be 3 times this number squared. All right, so that gives me 12.905. 12.905. So now I just keep doing this. So my x3 is going to be, I'll go ahead and again write the form x2 minus f of x1, sorry, x2, these are all 2's, f prime of x2. All right, so that's going to be my x2 is the 2.074 minus, all right, my f of x2 is the 6.922 over my f prime of x2, which is the 12.905. And so I get, so we need to do the 2.074 number, which is this one, minus the 6.922 number, which is this one, divided by the 12.905 number, which is this one. And we get 1.538. All right, so what we're doing here is generating a sequence of numbers, 3, 2.074, 1.538. It's a sequence of numbers that is going to be approaching our solution. We'll just do one more because I'm doing this out in a lot of explicit ways so that we can see everything that's going on. But we can take advantage of some calculator tricks to make things go easier, like by a lot. So we'll look at calculator tricks next. I'm going to calculate one more using the full process just to complete the process. F of x3 is going to be, so I need to do this number cubed minus 2. So my 1.537 number cubed minus 2. So I got 1.636. Yeah, just checking, make sure that's right. 1.636. And then my f prime of x3. Of course, all these equals are really approximately equal, but again, everything's approximate. And then so my f prime of x3 is going to be 3 times the 1.573 number, right? Yeah. Squared. See, there's got to be good ways to take advantage of your calculator's capacity to simplify this process, right? And there is. I have a different f prime of x3 than I did last time. Did I put that in right? I did 3 times the 1.537 number squared. Yeah. I think it's right. Don't you? Yeah, let's say it's right. So I did it wrong the first time. 7.093. And then so our x4, which is equal to x3 minus f of x3 over f prime of x3 is equal to, how did I write that last one like that? Okay, so it's going to be my x3, which is 1.538, minus 1.636 over 7.093. So I have the, so we're going to put this like that. That works. Kind of a little bit of glare, but not too bad. All right, so I want the, starting with the 1.538 number, all right, minus the 1.636, which is here, divided by the 7.093, which is here, and then enter. All right, we got 1.307. So you're going to notice some things about the sequence of numbers as you go along. You're going to see that the sequence of numbers, like the amount that the number changes by decreases every time, so which indicates that we're approaching a limit, which in fact we are, and we'll discuss later. Then the other question is, all right, we've done 3 iterations of the process to get to x4. So how close are we to the actual root, which we know is really cube root of 2? Let's see how close we are. So to get cube root of 2, I go math, 4, 2, enter. Okay, the real cube root of 2 is 1.259. So it's sort of taking its time to converge on that number. We're not all that close yet. But you can see that it's headed that direction. Also, why is it converging slowly is because we chose a number that was pretty far from the root to begin with. So if what we've done is if you look at sort of the curve and think about the iterative process, right? I'll try to exaggerate the picture a little bit. So the real root is down here, and we started with a number way over here. And we followed that tangent down. This is basically the process. This is x1, this is x2, and then we went up and followed that tangent down. And that's x3, and then we go up and follow that tangent down. And this is what's happening, okay? So, but we're not all that close to the root yet because we started so far away. So that's why that starting value, that's sometimes we call a seed value that you put in when it asks you for the guess in the graphing screen. That's important because it affects how quickly the method is going to converge, and other things as well. All right, so next we're going to look at another example, and we're going to try and condense the process quite a bit, taking advantage of the calculator capabilities.